Good afternoon, everyone. Thanks for showing up this late in the conference. We thought most of you would have already been back on your travels, but good to see that the GDPR topic is drawing so much interest on a late Thursday afternoon at the end of the conference. Anyway, so my name is Srikanth Venkat. I'm part of the product management team at Cloudera. I come from the legacy Hortonworks side. I was responsible in Hortonworks for the security and governance portfolio that included some of the projects that you might be familiar with: Apache Knox, Apache Ranger, Apache Atlas, and also Data Steward Studio, all of which we'll talk about a little bit in detail here. And with me here is Madan. Why don't you go ahead?
I'm Madan Nitiraj. I'm part of engineering team. His counterpart in engineering for security and governance. Basically, he tells us what's important for us to do. He prioritizes our work, and we do that.
He's being very modest here. So anyway, all right. So agenda here, we have a lot of stuff to cover, so we'll kind of speed through it quickly. The first one is we want to kind of set up the background just to see what does trusted data lake mean, especially in the age of GDPR. What are some of the elements that you need to pay attention to as you build out your data lakes and fill them with data? And there's going to be all kinds of personal, toxic, all kinds of data that goes in there over time. So how do we kind of make sense of all of that? Then we'll start with a couple of updates on the Ranger side over the last year or so. We have some very cool things that can help with some of the GDPR items, and then similarly we'll cover Atlas updates, and then we'll do a little bit of a double click into Data Steward Studio, which is a new product that we launched actually in last year at the same time in Berlin in DataWorks Summit in Europe. And then we've got a bunch of progress on that. We want to kind of share those details and show you some of the capabilities, and how that can help with GDPR. And we'll summarize very quickly with the feature set there. Okay. So when you look at building a trusted data lake, there are several items you want to pay attention to. So what you see here is a few of those capabilities. Across the Apache projects and between Hortonworks and Cloudera Technologies, we have capabilities in almost all of these areas, with the exception of master data management or MDM. Most of the other things, we have some technology enablers to cover those areas. For example, data profiling, we will see today in Data Steward Studio, access control via Ranger, Sentry, etc., metadata management and governance via Ranger and Atlas and Navigator, data retention and archival. We have a variety of tools around that. Business definitions, data lineage, all of these coming from Atlas and Navigator, and auditing via Ranger, for example. So we have capabilities around different parts of our stacks for what you would need to build a trusted data lake in this new age, where you have all kinds of personal data, probably distributed, that you want to put responsible controls around, and in order to satisfy compliance needs as well as regulations. So what does it mean to have trusted data? So trusted data means you need to be able to discover what data is stored where. You need to be able to have provenance and lineage information. You need to be able to secure that data appropriately, depending on the usage and the context for that within an enterprise, and be able to understand who has the authorization to access the data and who has accessed the data. So both the forward-looking as well as the retrospective usage of that. And how do you enable self-service in this kind of environment? And how do you manage, create, and apply these policies, whether it's governance policies or security authorization types of policies? And how do you ensure that all of this metadata remains consistent and is retained along with any kind of movement across the ecosystem for this type of data? So that's what we believe are some of the considerations that most of our customers and the community at large is trying to answer. And then we'll kind of cover how this impacts, especially from a GDPR perspective, and how some of the Apache projects as well as our technologies help give you some solutions around this. So this is your major considerations for GDPR. So I won't go into each of these. Most of you probably know. It's been around for almost 9 months now, and there's a whole bunch of major areas of responsibilities for any organization, from breach notification to right to access, right to be forgotten, consent monitoring, as well as privacy by design. So if any of you were at the GDPR crash course workshop that we just did a couple of hours ago, we did cover some of the consent as well as the RTBF kind of areas and how some of our technologies help with that. What we wanted to focus on in this talk is to kind of give you guys this picture to say, here are some, here's a sort of a mapping of the technologies both in the open source as well as outside, and then how they sort of address some of the considerations that GDPR places, especially on top that you see there. So on the bottom is our core bread and butter of our platform, which is the HDFS and Yarn for the compute and storage. And then we have in the middle layer the metadata governance and security layers, as well as the SQL layer with Hive. And you can see how they kind of interplay with a lot of the capabilities that we'll be talking about that's important for GDPR. And then on top, we have a solution that is Data Steward Studio that leverages all of these open source projects and gives you a comprehensive single view of all of that data across multiple data lakes. And then on top, you see the provisions that it maps to. So for example, purpose, usage, data protection, etc. On the right is Metron, which is our cybersecurity solution. There are probably a couple of other talks in the conference on that. So that is a separate pillar that will satisfy your breach notification requirements around GDPR. Okay, so what we believe is the path to GDPR compliance. Here's a set of things that you need to pay attention to. In your data lake environments, you want to be able to identify where the data is, especially the personal sensitive data, for example. Understand where it came from, what is the different operations through which it went through, understand the provenance, origin, and lineage, and then so you can understand what the impact of that data is as transformations unfold throughout the ecosystem. You want to be able to classify that with appropriate business purpose and other business context attached to that data. You want to be able to do this in a centralized fashion, so you can control the access and auditing and monitoring of that access in one place. And then anonymization, pseudonymization, or other approaches you would need to make sure that the personal data is protected appropriately, and doing all of this as much in an automated fashion as possible. So we believe that these pillars are what typically would constitute what you would build into a GDPR compliance program at enterprises, and definitely we will be happy to take discuss one-on-one with you guys later on and in the Q&A section if there are other things you want to add to this. I'm going to hand over now to Madan to talk through some of the community innovations in each of these projects.
Yeah, we look at few features we added recently in Ranger and Atlas. So we'll go through like 2 or 3 features in Ranger first, then followed with some features in Atlas which can address some of the concerns Shrikant listed. So the first one is, in Ranger we added a feature called, in the policies you can specify a specific time period in which the policy should be effective. This can be used to restrict access to resources for a certain period only. So instead of having to on real time go and recreate a policy to give access, and then at a certain time go back and remove the policy, you can create a policy upfront and specify a time period at what time the policy should be effective, it should begin effective, and then when it should expire. And this can be used for cases like temporarily allowing access to some users or temporarily denying access for certain resources. Right. And this can also be used for predetermined maintenance schedules that requires resources should be accessed only by very selective processes, not by everyone. So you can set up a policy which will deny access for everyone except the designated users, like backup or recovery. Right?
Yeah, this could be both a positive and a negative policy in the sense that you could temporarily allow access to certain resources. Maybe you need to have an override around a particular user who otherwise would not be able to access that. An example is, let's say an intern is in your finance department. Normally the interns are prohibited from touching those resources, but this particular intern happens to be in that department. So you need to give him access in the summer months to those resources. So this kind of policy can be used for that. The negative version of this policy is where you want to block a particular user out because maybe their account got breached or something like that. So you want to put a block on those resources and say, until my forensic team has gone and done the analysis, we don't want this user to get access to these resources. So you can use that to blacklist and disallow temporarily access.
And when you specify the time here, you can specify which time zone the policy enforcement should be, especially in case of multiple zones being covered by the same policy authoring tool. This becomes very critical. You can specify that it should be effective on the local time zone where the resource access is happening, or you can specify a specific time zone. It has to be GMT or any other time zone, right? And in addition, Atlas also supports this scheduling concept in classifications. So you can attach classifications like sensitive report to a specific resource, but you can say between what time the report is sensitive. If there's earnings report is going to go out in third week of, let's say, March. And you can say that report is sensitive only until that period. After that, the classification gets removed automatically. So any policies you have written for sensitive report will be effective only for the time period which is given. Is this the demo?
Yeah. So I'll do it.
Okay. So here's a policy which is going to be effective for scheduled maintenance window. So there's a user called ETL user. That's the only user who should be allowed to access a specific Hive database. All other users should be prevented from accessing it. So here it sets a schedule window from 12:45 to 11 o'clock at night that day. And you create a policy upfront, even weeks before you create this policy. And this policy says for the public, all access is denied here. Right.
There we go.
And then there's another policy which says for HR database, ETL user should be allowed select. So this one doesn't have any validity period associated with that, right? So this user is allowed to access anytime, but everybody else will be denied access during the time window specified in the previous policy.
So I think what we're doing here is we're showing logged in as each of these users what the behavior is. So when the ETL job runs, that is allowed access even during that window, but the analyst who was otherwise allowed is blocked because of that other policy. So you'll see a temporary block and a temporary override, both in this case.
From the audit log, you can go and find out which policy actually denied access to it. Now, it says that there's a policy which has a time period from 12 o'clock to 11 at night, and it denied access to it.
And this is the flip side of it, which is showing that service account, what is the behavior? So the service account is not blocked during that window. That is still allowed because of the override.
This is ETL user trying to do a select on one of the tables in HR database, and that access was allowed by.
Yep. Cool. I think it's good.
No.
Pause this here.
Okay.
This one we just talked through.
In a lot of situations, you want certain users or users with certain roles like auditors to be able to see the policies, but without having ability to make any changes to the policies. So this was one of the features we added in a very recent version of Ranger. So these users have full access to go and look at all the policies, what permissions are available for what users on which resources, but they will not be able to make any changes here.
Yeah, so the read-only user here has global access to view all the items, but they don't have access to edit. I think we can skip
this.
it.
Okay?
Yeah, we can skip it. The interesting thing here is that you can give this, maybe you have compliance folks who are asking for auditing all of these policies from a GDPR or other perspective. You can just give them access to the system directly and have them go look at this without any risk that they will go modify any policies or change any behavior in the system. So it gives you a very nice way to separate those roles out and get your compliance activity checked off.
And they can look at a live system instead of having to go through any report which you might need to generate otherwise. Yeah.
All right, go to the next one.
Yeah, next one. So another requirement is frequently you might want to see, given a specific user, what are all the tables and databases, columns they have access to. This is one of the frequent asks from the compliance perspective. So recently we added a feature in Ranger, which is exposed through Hive. So Hive has a feature called information schema, where you can go and run a SQL query and they select from permissions where the username is X and select all the tables there. So this will return all the tables the user has access, and it will also return what kind of access they have on the table, whether they have select access or insert access or drop access. This is currently available for Hive, but there are Ranger APIs available which can give the same information for any other service where Ranger authorizer exists.
Yeah, Hive is the only service which has implemented this first class. So if you have Hive 3 set up, Hive 3 actually polls Ranger periodically for the policy set and creates these tables and refreshes them. So you can statically run SQL and then figure out what kind of access a particular user has against a particular table. That's what this is being shown here.
Yeah, the information schema is a table populated by Hive itself, which has all the entitlements for each user to the level of columns. And you can run Hive query against this table to get the information. And this table is populated periodically with Ranger authorization policies information. As you make changes to the Ranger policies, the content of these tables get refreshed. So you have a SQL access to the privileges information.
Right. So what this is showing is, again, the Zeppelin notebook is showing the user accessing that table. And then when you make a policy change, you'll see that the privileges get updated. So we'll make these slides available so you can run these things inline and check out what the behavior is. So
this query is checking which users have permission on UK employees table. You should come back and show that.
Yeah, it's going back. It's looping. Yeah, so basically, you can check both at the table level and column level. And then what this is doing is it's doing an update and then running as that particular user to see whether the privileges got updated. And you see, when you run the query, you see all of the other data that's added here now. So you'll see the new set of permissions on the table. Yeah, okay. I think we should skip this one.
Yeah.
This is the same.
This another recent feature addition is to be able to add labels to policies in Ranger. This can be used for multiple purposes. So one way is, I think there was one question yesterday, they wanted to see how do you tie a specific policy requirement from GDPR to set of policies in Ranger. Because in Ranger there are policies, you can name them with different names, but how do you tie them to a specific policy requirement in a higher, from a higher system? So you can add policies here. For example, in this case, there are a couple of labels here, customers and employees. And any policy which talks about authorization for customer-related data, you can label them as customers. And then you can do a search in Ranger for a given label, and you can look at all the policies which match that label.
So one of the use cases here could be we have the auditor, the access auditor feature. So the access auditor can go and group these things by, let's say, if you label this with different class of GDPR, maybe Article 6 or something that boils down to a set of policies that you have around access control, then they can go look at it to say, okay, what policies do you have? And they can actually go look at the details of the policy to understand that you have the right compensating controls in place.
Especially if you have hundreds of policies, it might be difficult to see from the policy content what this policy is about, because you could have literally like hundreds of thousands of tables in your enterprise. And somebody who knows about the table, a lot of details, they went and did it. But for an auditor who is coming in, that may be not an easy thing to navigate through. So these labels help them to understand the policy. So now let's take a look at few features in Atlas. So one of the recent additions in Atlas 1.0 is classification propagation. So where if, let's take this case of medical records in a file gets loaded into one of the tables in Hive, right? Now, the discovery tools can go and scan these files and identify that this file had a personally identified PII information, and then it can go and add a classification to the file. The fact that the Hive database, Hive table got data from this file, so the classification automatically is applied to the table as well. So there are two pieces of information which makes this possible. One is when the table was created, there's Atlas Hive hook which captures the information that this table was populated with data from a specific file. So that information is the lineage information is kept in Atlas. And then when somebody adds a classification using like a discovery tool or manually comes and add information classification, that gets propagated to where all this data moved to. Later on, let's say if another view was created on top of this table, that view also will get this classification automatically.
So this will help you with chain of custody kind of use cases where you have a pipeline of different transformations happening in your enterprise. You want to be able to label one part of the pipeline as early as possible and have those classifications or business context preserved as you do the transformations throughout your data supply chain, essentially.
And there are more controls in the classification propagation. For example, what we call these are edges and vertices, we call them. So if one of the data set, when it was derived from other one, if the sensitive information has been dropped or it has been masked, then you don't want the classification to follow to the data set which doesn't have sensitive information. So you have options to go and change the propagation at each of the edge level. You can click on the edge and you can look at what are the classifications getting propagated through the edge. And you can say mark certain classifications to be not propagated through the edge, through specific edges. So in some cases, there's a table called employees mask. So the process there could have used some UDF to transform the information about sensitive information. It could have applied hash. So the sensitive information doesn't go all the way up to the employee mask table, so there is no need to enforce PAI policies on the employee mask table. So you can go and change the propagation at each edge level. So you have much fine-grained control on this.
So the default behavior is to propagate the classifications. So this gives you the ability to selectively block the propagation originating from a particular edge. So what that means is anything downstream in the linear chain from that point forward will not inherit that tag. Then we can go selectively choose which tags you don't want to propagate. So you can click on a particular edge and say, I don't want to propagate the PII tag alone, but I want to propagate the other tags because there are other line of business or other types of tags that we have added on the system. So it gives you a lot of flexibility in terms of how you manage this data pipeline with the default behavior to give you the chain of custody picture that's complete.
Yeah, this is the same use case, but in a more video. But we are running short of time, so maybe we can look at it later.
Yeah. So this actually, the video just shows that this is the propagation in action. So we put the tag on this, and then we go to the other entity at the other end to show you that the tag has actually gone there automatically just because of the lineage information.
Okay. So the other addition in 1.0 release of Apache Atlas is very fine-grained control on metadata operations. For example, you can set controls who can add PA classification to what kind of entities. So if you have set of Hive tables, you can go up to the table level. On this table or in this column, only certain users can add classifications. Or if a classification is added, certain users can only remove a classification. So there are fine-grained control on every metadata operations. So this will help you enforce that the classifications are, changes to classifications are very much controlled. And you can control to the level of let's say a specific Hive table, if it belongs to a certain business unit, you can say only the business owners can make changes to the classification on those tables.
So in the more extreme case, if you don't want people to even know about the fact that there is a tag called PII in your system, you can write a policy that says for these sets of users, don't even allow them to see the fact that there is a tag called PII that they may, by mistake, they may attach to an asset in Atlas and trigger a security policy that may have unintended consequences. I think we can skip the demo. Yeah, this one's showing just the things in action. Yeah.
And this one we covered already. It's a time-bound classifications. Very similar to in Ranger policies, you can have a start and end time. Here, this is about the classifications. You can mark certain you can choose to mark classification to have a start time and end time. And then the classification will be applied only during that interval. After that, the classification will not be associated with the entity. So Ranger will not enforce any policies for that. So this can be used for classifications like not public. You can choose to make data not public until certain time. After that, it can become a public.
What's the same thing?
This is again the demo of the same thing. So I'll just run through this. Okay.
Yeah, cool. So another key feature we added in Atlas 1.0 onwards is the business glossary. So we now provide a full-blown business glossary with full semantics that you might expect from a catalog here. So what this provides is the ability for you to define terms as a flat list within a glossary, and a way to group terms from different glossaries in an orthogonal fashion with categories. So this gives you the ability to take a business term and attach it to different assets that are sitting in the ecosystem in Hadoop or HBase or Hive or wherever, or whatever other assets that you might have on the ecosystem side. So the association can also give you the nice tag-based kind of approach in terms of attaching tags to those assets against those business terms and having them propagate and having them be controlled via range of policies. So the categories could be in a hierarchy, and then we can have orthogonal management of the terms and the metadata associated with those items. So what we'll see next is just a couple of the screens here. So we have a new glossary tab, and then there's the terms and category toggles. And then you can look at terms, search for those, search for categories. All of those search capabilities that you have in Atlas are enhanced for this. This one is just showing you creation and deletion of terms. This one is showing you search on terms and categories. And this one is showing you the semantics around this. So for example, we have full semantics around replacement terms, preferred terms, synonyms, antonyms, and then the ability to attach classifications against those business terms and use them in the rest of your processing. Okay, so we'll switch gears a little bit and talk about Data Steward Studio next. So Data Steward Studio was a new product we announced last year around the same time in Berlin, in the DataWorks Summit. And it was designed to address some of these challenges that you see with GDPR, for example. So it gives you the ability to get an inventory of where your personal data might be, for example, around the different data lakes, and give you some privacy-based controls around this to say, at least getting a map of all of that data and understanding how the data is secured and what other contextual metadata that you have around that. And then gives you the ability to understand how that personal data is being utilized in the enterprise in terms of auditing and capabilities around ranger audits, aggregating those, and providing ongoing monitoring of those across the ecosystem. So what does it mean to understand the data? So it's these things here, very simple stuff. So where is the data? What is it about? Who owns this data? Who has access to this? Who has access to this? Why was this collected? When was this collected? And how was this collected? All of these are important things you would need to consider for your trusted data lakes. And the way Data Steward Studio does this is kind of captured in this cartoon here. Think of Data Steward Studio as a fabric that provides you this catalog and business glossary, gives you the ability to curate your data assets, gives you a single view of these assets, and then gives you metadata and security picture around that. What you'll see here is you have multiple data centers and clusters in those, and they're all attached to the same fabric, and they're able to get all this insight from a single pane of glass on that. Data Steward Studio is designed for these two personas, the data stewards, who are the business counterparts who manage these business requirements around data sharing and responsible governance policies around those. And data curators are the ones who, the IT counterparts of the business data stewards. In terms of capabilities, Data Steward Studio, the one word to remember is discover, where each of the letters stands for a particular operation that you can do within Data Steward Studio. D is for detect, so we have profilers that come part of Data Steward Studio that go and detect different types of sensitive data and auto-classify them. We have an inventory or catalog, which is coming from Atlas, so you can go discover different assets by just querying and filtering those. You can understand how the data is secured, so all of the range of policies against assets are shown in a nice consolidated view. We have organizational construct called an asset collection. Think of this as a way to flexibly group different assets and organize them so that it makes sense from the business context of usage of those collection of assets. An example could be, let's say, in a healthcare setting, you have patient data. The patient data could be sitting as image files sitting in HDFS and some transactional data coming from, let's say, a Hive table of all of the customers' visits to a hospital or provider. And then these can all be grouped together as an asset collection and can be shared with others in the enterprise and annotated and enriched. So that speaks to the collaboration angle. So we have some very basic collaboration capabilities around the asset collections, such as crowdsourcing, rating, and favoriting and things like that. And then you can have threaded discussions on the asset collections, so you can share information about those as asset collections in the enterprise. There's also chain of custody piece, so whatever you saw in Atlas gets reflected up on the assets in an asset collection, so you'll get a consolidated picture of the lineage and cross-cluster behavior on that. We also provide enrichment, so you can add additional tags to assets and also label them in other manners. So anything that you can do in Atlas, those tags can also be added from the central location, so you can deal with it in one pane of glass across multiple clusters. There's also some built-in reports and dashboards. We'll take a very quick look at those in the demo. Let's switch over here.
Will you have time for Q&A?
Yeah.
It's already 10, only 10.
Yeah, let's finish it quickly. Yeah. All right, so this is the data plane console.
That's not showing up. Do you have to be in the presentation mode for some? Is it mirror? Can you put it in mirror?
Yeah, it is mirror.
It's not mirror.
Okay.
Because it was in
No
presentation mode
Yep.
before. Oops.
All right, thank you. All right, so this is the data plane console. So what we see here is two clusters in different regions that are attached to this data plane. Data plane is a new platform that we've introduced in the last year on the Hotmook side that helps you connect to different clusters or data lakes that may exist in different places and enable a consolidated view and give you the ability to manage all those assets in a systematic fashion from a security and governance perspective. So within that, we have the Data Steward Studio as an application. So we'll go look at that very quickly here. Okay, I'm going to switch over here. All right. So one of the first views will get presented. My apologies, this thing takes a while to refresh because it's running on VPN over Wi-Fi. So when this refreshes, you will see a summary of all of the assets in that data lake. So we give you information about how many total assets are there, how many have been profiled, how many are in a sensitive state, and how many have been accessed and over what period of time. Okay, let's see if that's any better here. No.
I think you probably lost the internet.
Last connection here.
Yeah, it's not connected. Oops. We were lucky yesterday.
Yeah.
We were able to pull off
Demo
three
gods are
different.
not kind to us today. Okay, let's try a different way.
That's probably why you didn't put a new tab.
Yeah. There we go. Okay, I'm going to go switch into Data Steward Studio. All right, so what you'll see here is those two clusters. Now you will see hopefully all the widgets populated here faster. So the idea here is we give you a summary of all of the assets in the data lake and give you different views of how many have been profiled, how many have sensitive data, what is the total number of tables in there, how many of those sensitive assets have been touched over the past day, month, whatever the case may be. All right, there we go. That's much better. So you see here, for example, there are so many assets, 21 assets here, out of which 7 are sensitive, 14 are non-sensitive. What are the top tables that have been touched and how frequently? So, for example, this table called US customers has been touched 4,200 times over the last month or so. So we give you aggregated usage stats, we give you the asset collection-based stats, and we give you sensitivity-based stats at the dashboard level. Then you build asset collections. It's very simple to build those. And if it'll let me log in.
Maybe you have 5 minutes if you want to go on anything else.
Okay. All right, so there's an asset collection here, and we have a similar dashboard for the asset collections, which will give you, where's the sensitive data, how is that distributed, et cetera. And it will also give you information when this panes. Oh, wonderful. There we go. So we have an asset collection, which we have built with multiple assets in it. Now we are drilling down into a particular asset. So it's a table here. This is a US customers table that potentially comes from a CRM system for this organization. and we give you a consolidated view of all of the things that you would see in Ranger, Atlas, and other places in a consolidated fashion here. So see, for example, how many rows and columns. You see the Atlas lineage here, so you can look at all of the metadata. You can look at the Ranger access patterns here. There's no data here in terms of access requests. You can see the classifications that have been set on the asset in Atlas. You can see a lot of the technical metadata on the assets. We also have other profilers that go and look at doing column univariate statistical profiles. So you see here histograms and fine number summaries. And if you have categorical data, you will see other types of plots, such as this. So you'll see, in this case, you show a pie chart for categorical data, and for numeric data, you will see those histograms. You also see here the sensitivity profilers go and they classify the columns, auto-classify the columns. In this case, this column has been flagged as having social security numbers and telephone numbers on this other column. The data stewards can go in and accept these, or they can say, hey, I don't think this is right. This is a false positive, so they can go back in here and attach a different label classification to this. Out of the box, we support about 75 plus items. Majority of those are GDPR specific. So, for example, IBAN numbers of the 26 member nations, passport numbers, and other patterns, as well as email, social security numbers, the common things that you would want to detect and protect here. These profilers can also be customized. You can write your own profilers to detect different things. Oh my God, this is dropping.
I think because you didn't sign on to the core one. That's okay.
Dropping every time. Okay. At least just remember where I was last time. Okay. So the profiler settings here shows you what profilers have been running. There are multiple profilers that come out of the box. We have a column profiler that goes and looks at the content within the columns and generates those univariate statistics that you saw. There's also a Metastore profiler that gives you the count of all of the Hive assets that are in there. There's a Ranger audit profiler that goes and summarizes all the audits that you see, those widgets where you saw the access patterns and the trends around those. There's also the sensitive profiler. You can write your own profilers if you don't find any of these elements. So these are the ones that we provide out of the box. It's a long list here. If you want to write your own, it's very simple. You go in here and you add, for example, a regex plus lookup as a whitelist or a blacklist, and you can also add other algorithmic logic. And you can tie any combination of these things into your logic, and then say if you see this pattern and the data is part of this whitelist or blacklist item, and it also satisfies this other semantics in terms of, let's say, a Luntz check digit or something like that, you can put all of those things together and say, if you see all of these conditions, then you classify this column as having this type of sensitivity or some other label that you want to attach. And then you can do that both based on a column name as well as a column content. So we give you some flexibility on this. In the next versions, we'll start making this a little bit more machine learning driven. So we'll have a lot more capabilities around auto detection, auto classification of these things. So the amount of work you need to do to manually classify these goes down quite a bit. So this will help you create that, at least a baseline of the inventory of where all of this sensitive data is across your data lakes. And since this talks to multiple data lakes, you can look at your entire data lake footprint and get that insight around where all of this personal data is getting strewn around in your enterprise landscape. So that's a very quick tour through this. I think we are pretty much out of time, so we can, we'll have probably time for a couple of questions here. So let's see, go back here. I think that's all we had to go through here.
Yeah, we have to run through some of the demo because they're very short of time, but we'll be happy to take any questions
and we will hang around here, so if you
outside.
guys have questions on other stuff that we can do double clicks into those areas also. We probably have time for a couple of questions, so. Any questions? Go ahead. Metron, no, we're not talking about Metron here. No, Metron is not part of this at all. Metron is a separate thing. We just showed you that in context so that we have other solutions that are, that can be used for other parts of GDPR to satisfy other requirements of GDPR.
One question. It's not probably related to the GDPR stuff, but regarding Hive, is there any plan in the roadmap to include system tables where we can get the metadata information about the Hive system tables? So right now, if we need,
You'll have to ask the Hive team that. No, we'll take that question back. We don't have the answer for you on that one.
Okay.
Right. Right. Actually, we can talk offline. But there's a sys table and information schema table. They are all captured in Atlas, if that's what you're looking for. But we can talk more.
Yeah, because I don't know whether you were talking about the population of those or whether you're talking about the access to those.
No, so for example, like in the relational databases, or you have the system or catalog tables where you get and right now if we need that, we have to go to the actual backend database, MySQL.
Actually, Hive just implemented. That's what I showed.
That's the
information schema which we talked about. That's exactly what the RDBMS have. The Hive has implemented now.
So you said, but that only stores the access details. Or
No, the access is only one of the tables in there. There's a bunch of other stuff.
This information schema is actually referring
it's
to
the SQL standard. There's a SQL standard for information schema they've implemented.
There's a database called information schema. It's got a bunch of tables. One of the tables has the privileges information.
Okay. Okay. Interesting. Thank you.
Yeah.
How about security on this nested structures? For example, if you have a structure.
Right. This question came up in yesterday during Ranger presentation. What I said is, this is the first time I'm hearing on the security on the nested structure. This is not available right now because when Hive consults Ranger for authorization, they just give the column name. They don't break it into individual pieces of the column. So right now it's not available. But if this is something more useful, I think we can work with the Hive team to see the possibility of adding like UDFs and all for the subfields of a column. Right. The best way to address this is to basically to get a Hive Jira in place, so then we can track it with the Hive team.
Sure. Also for non-Hive queries, like for example Spark accessing the HDFS layer directly, how do you propagate the PI information? Do you have something in mind for that? Or are you looking at a solution?
So if Spark is accessing the files directly, then the column level the classification will not go into the file. But if there is something at the table level, we can propagate into the file. That's possible to do that. But having the column level information go into the entire file, there is no answer for that right now. So one way is to go access the file information via Hive Arrows connector. Instead of Spark directly go to file, you can go to Hive LLAP, and that will enforce all the policies written for Hive tables.
And in that case, the transformation may also link it up via lineage. So it's a file to file, and then you may be able to see some of the characteristics there.
And how do you block the access to HDFS layer? So because your policies are now applied at a user level, and now if you're going via Hive, you have to ensure Spark users don't access directly to HDFS, right?
Correct.
Right.
And because if you bypass row level and column level security at Hive by going to HDFS, then the whole point of security is gone.
Correct.
So in that case, you can put HDFS policies also.
Correct. Our recommendation is first to lock the HDFS access to only Hive process. So it will be like do as equal to false, so only Hive users will go there. Or you have to selectively enable access to HDFS for the specific user you trust.
Thanks.
Any other questions? Right. Okay, this one here. Yeah. So yeah, the DSS works on anything 265 and above, 5 and above. And 265 was introduced last May, if I remember correctly. So we've had about 9 months worth of run rate on that. It works on 3.1 also, but there's some behavioral changes we have added in Atlas and Ranger, etc. So you'll be able to leverage more things in 3.1 with the same setup. Any other questions? Go ahead. Yes, so that's a very good question. So we, at Cloudera, we are now creating this layer called SDX, which will include Atlas, Ranger, Knox, all of them as part of the fabric. DSS will be the way you consume the information in that fabric. So that gives you what is called a shared data experience, meaning it could be cloud stores, it could be on-prem. We give you one way to manage all of that data. and then be able to give you the insights on top, we'll have an experience like DSS. It may be called something else in the future, but the functionality that I showed you here is going to stay. It may just be branded something else in the future. Our marketing people are still at it, so. Any other questions? Go ahead. Can't hear you. Yeah, can you use mic?
Is this open source publicly, so people can obviously contribute additional features to the platform and obviously further integrations?
Yeah, so DSS is open source, but it's not Apache project. We have a repo and it's open, so we can share the information with you. We encourage the community to go take a look at it. It's not a typical Apache 2 license, it's what is called an AGPL license. But it's all the code is open source. Everything that I showed you here is all out there and open.
But Apache Ranger and Atlas, they are open source, and there are contributors from multiple companies and multiple countries in those projects.
Any other questions?
All right, thank you very
Cool.
much.
Thank you very much.
If you have more questions,
Yeah.
please catch us outside, then we are happy to